All right, this is video 18C. We're going to continue modeling the sample mean, so we're going to look at an example in this video. The length of a human pregnancy measured in days follows a normal model with a mean of 266 days and a standard deviation of 16 days. So let's look at some questions. First, draw a normal model for individual pregnancies. This isn't anything new. This goes back to, I think, lesson 12, where we looked at the normal model. This problem could have appeared, several lessons ago. So first, let's just draw the normal model. You know what the shape looks like here. The mean for individual pregnancies is 266 days. You can think of this, we're sort of modeling here the length of a pregnancy. And the standard deviation was 16. So from the mean, I can go up 1, 2, even 3 standard deviations from the mean. So if I add 16, add another 16, and add a third 16. Those are 1, 2, and 3 standard deviations above the mean. I'll do the same thing going the other direction here. And then we could even label, you'll recall that 68% of the time observations will fall within 1 standard deviation of the mean. 95% of the time will be within 2. Go out 2. And almost all of the time will be within 3 standard deviations of the mean. 99.7 roughly here. So that's what our normal model would look like for individual pregnancies. All right, let's look at B. B, what proportion of pregnancies last longer than 285 days, or 285 days or longer? You can sort of see where that will be here, and or longer, I'm looking out here. So I think I'll leave this picture. I'll just clean up the numbers a little bit, make it a little less busy here. So again, this is an old problem. You could have done this weeks ago, so this is a good review. Make sure you still know how to do this. And 285 was about right here. And we want the pregnancy to last that long or longer. We'd like to find that area right there. You should definitely know how to do this. Open up StatCrunch. Use that StatCrunch normal calculator. You know the mean, standard deviation 16. You're looking for the likelihood that X is greater than 285. And so if you use StatCrunch, you should get an answer of about, as a decimal, 0.1175. That comes from StatCrunch. What proportion of the pregnancies, we can leave it that way. You could convert this to a percentage. About 11.75% of the pregnancies will last 285 days or longer. So still nothing new in question B here. All right, how about C? What's the probability that any pregnancy lasts between 256 days and 276 days? Again, this is nothing new. This is just area under the normal model. I'd recommend for each of these parts that you draw yourself a new picture in each one. So draw yourself a new normal model. And this time we'd like to find the area from 276 down to 256. We're finding that area right there. Again, use StatCrunch, that normal calculator. It has that where you can find the area between 2 values, so check between at the top, and you're looking for the area between 256 and 276. You know the mean, standard deviation 16. So again, from StatCrunch, this area in here will be 0.4680. Or we could say about 46.8% of all pregnancies will last between 256 and 276 days. So A, B, and C have been complete review from what we did back in lesson 12. Let's look at D, see if we change things up a little bit. Okay. Now we take a random sample of 16 pregnancies. We're no longer looking at individual pregnancies. We'd like to answer a few questions about the mean length for these 16. So we're not looking at their individual length of time that they're pregnant. We're looking at the average amount of time that these 16 women are pregnant. So this is the new stuff now from lesson 18. So what do we ask here? What model will we use? Why can we use that model? Okay, since pregnancies, just Y, we just looked at that. Length of a pregnancy follows a normal model. When we now look at groups of 16, remember that the spread of this is going to change, but the shape will be the same. Since the original data followed a normal model, the sample means are also going to follow a normal model. They'll be centered at the same spot, still have an average of 266, but the spread is going to shrink. So, this distribution is going to look something a little bit more like that. So we can use the normal model. The reason why we can use the normal model, the original population was normally distributed, so despite having a smaller sample size here, it doesn't matter. The sample mean will also follow a normal model. So now I lost that question. There it is. Had the wrong paper. So the sample mean will also follow a normal model. Since the length of pregnancies was normal, the average length of pregnancies will also be normal. And along with that normal model, we need two things. We need to know where it's going to be centered and what the standard deviation is. So the center will be the same. The mean of the sample means will be the same, 266 days. But these sample means will not be as spread out as the length of the individual length of pregnancies. So we'll take that standard deviation, from our original model there and divide by the square root of our sample size. Our sample size in this case is 16. So the standard deviation was 16. Our sample size was 16. Those aren't always the same numbers, just happen to be in this case. But this was the standard deviation. We sampled 16 women. If you take 16 divided by 4, we'll get a standard deviation now of only 4 days. So individual length of pregnancies had a standard deviation of 16 days, but when I start to look at groups of 16 women, the average, the distribution of their average length of pregnancy only has a spread of 4 days. All right, so this is what we're going to use in the next couple of questions here. So now draw the model for the mean length of 16 randomly selected pregnancies. We're going to make this picture over here bigger, and we'll comment. So really we're just going to draw this picture. We have our mean now. We know what the new standard deviation here is, and we can see what we would expect for the average length of pregnancy for 16 women. So let's draw that. So still centered at 266 days, but this is something different now. This is no longer Y. This is the sample mean. not individual pregnancy lengths, but average pregnancy lengths for 16 women. And again, we can go out 1, 2, and 3 standard deviations, but the standard deviation now is only 4. So moving up 1 standard deviation, I'll be at 270, 274, 278. And then I can do the same thing the other way. So if you compare this to the one we did earlier too, you can see that those numbers are much less spread out than they were for individual pregnancies. 262 will squeeze in there. And you know, same rules apply. 68% of the time, if we have 16 women, we'd expect the average length of their pregnancy to be somewhere between 262 and 270 days. And 95% of the time within 2 standard deviations, and almost all of the time within 3. But keep this straight from what you had earlier. This is the average length of pregnancy for 16 women, not individual pregnancy lengths. And again, centered at the same spot, but a lot less varied than it was for individual pregnancies. And it should kind of make sense too, and you can imagine as you increase the number of women that you looked at, if we did this again and we sampled 100 women, the average for 100 women, those averages are going to vary a lot, even less. This distribution would get even narrower, have less spread. Okay, what percentage of the time will 16 randomly selected women have a mean length of pregnancy of at least 285 days? Seems kind of familiar that we almost answered a question similar to this a few minutes ago, but this is different. Be careful. We're looking at 16 women, not an individual woman's pregnancy, but that the average length of time that these 16 women are pregnant is at least 285 days. This is the distribution we're looking at now. And if you look on here and think about where 285 is, 285 is going to be pretty far over here, clearly well beyond 3 standard deviations above the mean. So maybe I clean this up. This does not seem like this is going to be very likely for this to happen here. If I go up another 4, where am I? I'm at 282. If I go up another 4, I'm at 286. This is, about out here. Pretty far out in that tail. And we're looking here at least, meaning 285 days or longer. I can already tell just based on the picture, this is not very likely. You could use StatCrunch to verify this if you'd like. If you use StatCrunch, be careful. When you put in the mean is 266. Your standard deviation is no longer 16. The standard deviation for the sample mean is 4. And if you then find that area, here it is. I count all these zeros. We have 5 zeros and then a 1. 1, 2, 3, 4, 5, and then a 1. That's the area of that little tail there. If you convert this to a percentage, multiply by 100, this is still incredibly small here. 0, 0. Oh, I think I have 1 too many zeros. 3 zeros. There's a 0.0001% chance of this happening. So, how likely are you to get a group of 16 women, look at their average length of pregnancy and have it be 285 days or longer? You're almost likely to never have that happen here. The likelihood of that happening is 0.0001%, extremely small. Almost everybody, all 16 of those women would have to be well past term for that to happen too. That would be an extraordinarily unusual event for this to happen. If you were to think about what this is here, this is actually 1 in a million chance of this happening. So not very likely that that's ever going to occur. Whereas if you flip back a couple and look, the likelihood that an individual pregnancy lasts 285 days or longer, that wasn't as unusual there. But the likelihood that the sample mean is that big is very rare. All right, I think we've got one more. Still looking at a group of 16 women. What's the likelihood that the mean pregnancy length, again for all 16, is between 256 and 276 days? So I'll clean up this picture. I would encourage you to draw a new picture. Yeah, here. Up here. And we're looking for this area here. Again, still average length of pregnancy. You're going to do the same thing. You're going to go to StatCrunch. 266 is your mean. Your standard deviation, since it's the sample mean, is 4. And you can use the between button there at the top and find the area between 256 and 276. And if you do that, so just a note here that make sure you're still using a standard deviation of 4, not 16. But if you do this, you'll find that area in the middle there is 0.9876. Or almost 99% of the time that you look at samples of 16 women, the average length of their pregnancies will fall in this range. That's going to be some extremely common values. So maybe we just write up one summary sentence about this. 98.76% of the time, 16 women will have an average length of pregnancy within that range. Which was between 256 and 276 days. Again, we're still looking at groups of 16 women and the average length of their pregnancy, not individual pregnancy lengths. Okay, so that wraps up this video. Make sure that when you're looking at the normal model that you pay attention to the wording of the problem. Is this individual observations, or do I now have a sample and I'm looking at the sample mean and how the sample mean varies? Because you'll get very different answers there. The sample mean is going to vary a lot less than the original distribution will. All right, so that wraps up this one. Stay tuned. We'll do one more example.